We now discuss the solution of a problem from the section Sets, Relations and Functions. This given question is related to the equivalence relation. That is, the given question is related to the concept of the equivalence relation. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let A, capital A, is equal to A1 union A2 union etc. union AK, where AI intersection AJ is the empty set for I not equal to J, where 1 less than or equal to I, comma J less than or equal to K. Define the relation R from A to A by R is equal to the set of all ordered pairs x comma y such that y belongs to AI, A suffix I, if and only if x belongs to AI, where 1 less than or equal to I less than or equal to K. Then R is, we are given 4 options. Option A, reflexive, symmetric but not transitive. Option B, reflexive, transitive but not symmetric. Option C, reflexive but not symmetric and transitive. Option D, an equivalence relation. We are given a set A as the union of K sets. They are A1 union A2 union AK, where AI intersection AJ is empty. That means this A is the union of pairwise disjoint sets. And AI intersection AJ is an empty set for I not equal to J, where I comma J varies from 1 to K. And it is also given the definition of the relation what is considered in this problem. R is the relation from A to A defined by R is equal to set of all ordered pairs x comma y, where the second component y belongs to AI if and only if x belongs to AI for 1 less than or equal to I less than or equal to K. Then we have to discuss the reflexivity, symmetric nature and transitive nature of the relation R. That we do in the next slides. We now discuss the solution of the problem in detail. We have A is the union of K sets, A1 union A2 union AK. They are pairwise disjoint, right? Now, given R is a relation on A from A to A is same as on A defined by R is equal to the set of all ordered pairs x comma y, where the second component y belongs to AI if and only if x belongs to AI, 1 less than or equal to I less than or equal to K. It amounts to say that an ordered pair x comma y belongs to R if and only if both x and y come from the same set AI. That's what it says. Right. Let us consider an arbitrarily chosen point A. A is any element of A. So A is an element of A means A belongs to the union, A1 union A2 union AK. Now A belongs to one of them. Maybe it may belong to more than one set also. Let us say A belongs to A1 and A belongs to A2. Then in that case, A belongs to both A1 and A2 means A belongs to A1 intersection A2. But you know, AI intersection AJ is empty. Now A1 intersection A2 will be empty. That means A belongs to A1 intersection A2 implies A belongs to the empty set, which is not true. Therefore, when A belongs to capital A, then A belongs to exactly one of these sets A1, A2, etc. AK. That's the argument. So let A be any element of A. This implies A belongs to exactly one of the sets A1, A2, AK, say AI. This result follows from the fact that these sets A1, A2, AK are pairwise disjoint. Agreed. So we have considered A is an arbitrarily chosen element of A, then A belongs to exactly one of these sets A1, A2, AK, let us say AI. So A belongs to AI. Implies A belongs to AI implies and implied by A belongs to AI. Obviously, implies and implied by A belongs to AI. Now apply your definition of the relation R. So Y belongs to AI implies and implied by X belongs to AI will tell you the ordered pair X comma Y belongs to R. So from this what you get is the ordered pair X comma A belongs to R by the definition of the relation R. So this is true. How A is taken? A is any element. That means A is arbitrarily chosen. That means A comma A belongs to R for all A belongs to A. Therefore, R is a reflexive relation. That is the first outcome. Agreed. Agreed. Now we go to symmetric nature of the R. Let us see. Start. A comma B belongs to R. Apply the definition. B belongs to AI. A implies and implied by A belongs to AI for some I. Now you see this is a implies and implied by, both ways are there. B belongs to AI implies and implied by A belongs to AI. You will also get from this you get A belongs to AI implies and implied by B belongs to AI, because implies and implied on both sides is there. This implies A belongs to AI implies and implied by B belongs to AI. Now you apply the definition. That means A belongs to AI implies and implied by B belongs to AI is B comma A belongs to R. That means this talks about whenever A comma B belongs to R, then B comma A also belongs to R. That is what is called the symmetric nature of the reflexive and of the relation R. Therefore, R is a symmetric relation. Agreed. Now we go to the discussion of the transitivity of the relation R in the next slide. So to talk about the transitivity of the relation R, we take A comma B belongs to R and B comma C belongs to R. If you can prove this implies A comma C belongs to R, then R will be transitive. So let us write down the meanings of this one. A comma B belongs to R means definition is B belongs to AI implies and implied by A belongs to AI. So the red one, this is a suggestive notation I have used. A comma B belongs to R means B belongs to AI implies and implied by A belongs to AI for some I. What about B comma C belongs to R? This will be C belongs to AJ implies and implied by B belongs to AJ for some J. Yeah, this is what, of course, this is what I can write. I will allow J to come here. But you see now, you see B belongs to AI and here B belongs to AJ. That means B belongs to AI intersection AJ. If I not equal to J, then AI intersection AJ is empty. Then you will get B belongs to AI intersection AJ is empty. That means B belongs to an empty set. How come? This is not true. Phi is empty set. Empty set has no elements and B belongs to empty set is not possible. Therefore, I not equal to J, what you have taken is not true. Therefore, if you want to say B belongs to, say, that means I not equal to J is not possible. Therefore, I is equal to J. So now what happens? You rewrite. That means J is not there. This will be I only. So now come back. A comma B belongs to R and B comma C belongs to R implies B belongs to AI, implies and implied by A belongs to AI, if and only if. And C belongs to AI, if and only if B belongs to AI. Yeah, same I should get. I is equal to J, what we have proved. Therefore, for some I. Now read now. C belongs to AI, implies and implied by B belongs to AI. So the second statement we have written first. And the first statement, B belongs to AI, if and only if A belongs to AI, for some I. Now you see, B belongs to AI, implies and implied by A belongs to AI. So you connect them. C belongs to AI, implies and implied by B belongs to AI, implies and implied by A belongs to AI. Now connect. C belongs to AI, implies and implied by A belongs to AI for some I. That means A comma C belongs to R. Apply the definition. A comma C belongs to R. Agreed. So that means whenever A comma B belongs to R and B comma C belongs to R, then A comma C also belongs to R. This is precisely the transitive nature of the relation R. Therefore, R is transitive. Thus, we have proved R is reflexive, symmetric, and transitive. So, such a relation we have studied, that is the definition of an equivalence relation. Therefore, R is an equivalence relation. Let's look at our options. And R is an equivalence relation appears against option D. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem from the unit 1, that is sets, relations and functions. And the given question is related to the concept of equivalence relation. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.